Hi, my name is Alexander Wuolle. This is my third year here at UBC, and I'm a computer engineering student. So, growing up, I had a fascination with airplanes and technology. When I was 8, for my 8th birthday, I asked for the Jane's Recognition Manual of Airplanes. If you guys don't know what this is a manual about this thick that lists every single model of airplane in the world, and it shows all the different schematics for them. When I was in grade 10, I built my own pair of night vision goggles from scratch and used them around the house. So the combination of these two technologies is really applicable to my passion for UAVs. UAVs are unmanned aerial vehicles. Most people think of UAVs as drones. So UAVs have a very extensive history. This is probably the most well-known UAV. This is the MQ-9 Reaper. Very used a lot in Afghanistan and Iraq, and used a lot in the media. This is a Raven, developed by another company, also used mainly in Iraq and Afghanistan. This is a Global Hawk. It first premiered in 1993 and was used in the Middle East and as well as conflicts in Eastern Europe. This is the Fire Scout. It is used by the US Navy to track down pirates around the Gulf of Oman. So UAVs have a very extensive history, but they have a really positive future, not only in military applications, but in civilian applications. I have big aspirations for UAVs. UAVs can be used for many different things. They can be used to search for missing people lost in the forest. They can be used for searching out in houses while they're burning down to prevent firemen from losing their lives. So there are many different types of UAVs, and they have many different types of control. You can use a UAV and control it off just from a joystick thousands of miles away to just throwing it up in the air, and it does everything by itself. There are 4 main types of UAVs. The first is VTOL, vertical takeoff and landing. So as you can see, the routers here can rotate 90 degrees. So it can take off from a single spot and then fly straight away by the rotors rotating to 0 degrees. The next is a single rotor UAV. This looks like a helicopter. They can be as small as a hummingbird to as big as a full-sized helicopter. These are multicopters, so it can have anywhere from 3 to 8 different propellers on it. These have a very good maneuverability, but they have a small flight time. These multicopters can fly in through windows. They can do an assortment of different things. And the last is fixed-wing UAVs. So this is like my UAV here. This is my UAV. I built it myself. It can fly around. Fixed-wing UAVs, their specialty is they can fly at high altitudes for long distances, but they have a low maneuverability. There are many different applications and uses for UAVs. As you guys know, there is a military application, but there are also many different civilian applications. The first is filming. So imagine a scene of an avalanche cascading down a mountain, or imagine someone stuck in a glacier after climbing. Okay? UAVs can do multiple of different things. With filming, if you need to film a scene from inside a room to someone running out the door and the camera needing to sweep after them, you cannot do that with a boom. But with a UAV, you can attach a camera to a multicopter and have it follow them in the entire way in only one shot. A big application is search and rescue. This gives people an aerial view of what's happening around them and gives the search and rescue personnel a great view of what's happening. Used in search and rescue is FLIR cameras, forward-looking infrared cameras. Here's a picture of FLIR camera used in a forest, and here you can see 5 deer. Another type of camera is just infrared cameras with multispectrum. This allows users to look for heat signatures. So if you're lost and you slip down into a gully in the middle of the forest, personnel walking on the feet looking for you probably won't find you. But if they're able to pull out their pickup truck, roll a UAV out of the back of it, and take off within 20 minutes of you going missing, they're most likely to find you in that gully, and you're most likely to make it home. A huge application is geomapping. Right now, geomapping people use normal planes to fly up in the sky, take pictures of what's happening on the land below them, and then transfer those into 3D maps. But with UAVs, these companies are easily able to deploy a UAV at any time to the company's convenience. Another application is firefighting. Here again is a FLIR camera used to detect heat signatures. As I noted before, you can get a multicopter that you can throw in through a window. It'll search the house for that missing child hidden in his closet, fearing of the smoke and the fire, so the fireman doesn't have to go through the entire building. Another application is law enforcement. There's currently approximately 14 UAVs used with the RCMP for crash analysis. This allows the law enforcement units to get a better perspective of what happens and to view the evidence with better understanding. Another application is scientific research. On the left, you'll note a UAV, and that UAV is specifically used for tornado watch. It actually flies within the tornado and allows scientists to take different readings of what's happening without risking the life of anyone who's flying the plane. On the right is a UAV used with the British Scientific Association. It was used in Antarctica. They deployed 4 of them to take different thermal readings and other types of readings in order for research. Another application is crop management. Imagine you're a farmer. Every day you have to hop in your plane, fly for 4 or 5 hours over your crops, dusting them. But with a UAV, you can sit on your porch, drinking your iced tea, playing your banjo, and your UAV will take off automatically, fly over your crops automatically. When it needs to refuel or when it needs to retake up more crop dusting, it will park automatically, refill automatically, and keep on doing it until the job's done. Another application is oil and pipeline surveillance. This allows companies to deploy UAVs that fly back and forth along their pipelines, analyzing the pipelines to see if there's any errors. Allows for a constant management of these pipelines, and if anything goes wrong, they'll know immediately. Another application is Coast Guard. This is a UAV used with the British Coast Guard. Lots of times when there's an error and something goes wrong on your ship, it's because of bad weather. With extreme weather conditions, they aren't allowed to send up a pilot in a plane. So if you're on your boat's sinking, and you're floating in the middle of the ocean, huge waves crashing around you, you're going to want to be found, and they're able to send up a UAV, not risking anyone's life, to go find you. Another application is transportation. Imagine your car. You pull out of your driveway, and instead of just driving down the road, turning left at the stop sign, you drive down the road and you take off. All you need to do is set your GPS waypoint, and you'll fly to your next destination. Everything will be automated for you. Crash analysis will be automated for you. It'll detect if there's any birds or anything in the way, and it'll avoid signs. So as you can see, there are multiple of applications for civilians. The sky is a big open space. We're able to utilize it. We're able to use it, and we're able to do so by improving humanity, improving society, and improving people's lives, as well as saving lives. UAVs and aerial photography give everyone a different perspective. It allows you to see the greater system. It allows you to see the bigger picture, such as UBC. UBC has an amazing view. from up in the sky. I don't know. It also reduces extensive training. With UAVs, there's 1 or 2 different autopilots. When you're training in planes, you have to train for each specific model of plane. You have to go through hours of flight training to be able to fly on your own. But with UAVs, you're able to take out the control unit and plug it into a different UAV, and you're able to fly the same way. So you don't have to worry about extensive training. It also gives a safer transportation network. It can use automation and a whole bunch of signals, so you're able to actively reduce crashes and have a better transportation network. So I have many positive aspirations for UAVs. I hope they're used extensively in the future. I hope that people will view them in a better light, knowing that there are lots of civilian applications and not just military applications for this technology. As you can see, there's no machine gun strapped to my UAV. It can't do anything horrible other than probably crash into a field somewhere. So my aspirations is that you'll go home and you'll see these in a different light. You'll see these as a technology that we can apply to our everyday life, that we can apply to our businesses, and use this to better everything. Thank you very much for your attention.